Welcome back. Let's learn about percent mixture problems. All right, so another application of solving basic equations in algebra is the ability to solve percent mixture problems, which, in a way, are similar to the value mixture problems we looked at in the previous lesson. While value mixture problems focused on the dollar value of the amount of different ingredients in a mixture, percent mixture problems focus on an amount of an ingredient or substance in a mixture or solution based on percentages. And this is pretty common when considering mixtures involving liquids, which sometimes we call solutions. The amount of a substance in a liquid solution can be given as a percent of the total solution. For example, if a fruit drink is advertised as containing 25% grape juice, then 25% of the contents in this bottle must be grape juice. Right, so this particular drink is a 24-ounce drink that contains 25% grape juice. We could find the amount of grape juice in that liquid using this information. In total, there are 24 ounces of a liquid, but 25% of it is grape juice. So we could perform the following calculation. The amount of grape juice would be equal to those 24 ounces multiplied by 25%, or really you're taking 25% of 24. So you would multiply by the decimal form of that 25%. So that would be 0.25. Or really, you could think of it as just taking 1/4 of 24, since 25%, 1/4, and 0.25 all represent the same value. All right, so you can rewrite this calculation to be 24 times 1/4, and 24 times 1/4, or 24 divided by 4, is equal to 6. And so what that tells us is that the amount of grape juice in this drink is 6 ounces, right? There are 6 ounces of grape juice. And so what that tells us is that since this bottle has a total of 24 ounces of liquid, but contains 25% grape juice, then 6 of those 24 ounces are grape juice. All right, the other 18 ounces, 24 minus 6 is 18, the other 18 ounces are some other liquids. Okay, but the percent concentration for grape juice is 25%. And so we can multiply that by the total amount in the bottle to get the amount of that grape juice. All right, and so this calculation that we just did here can be generalized with the following equation. The equation is Q is equal to A times R, where Q is the quantity of a substance in a solution. So in our example, that would be the amount of grape juice. And you can calculate that by taking A, the total amount of the solution. So in our example, that was the 24 ounces in the bottle. And you multiply that by R, which is the percent concentration of the substance. In our example, the substance was grape juice, and the solution was 25% grape juice. So the percent concentration was 25%. Okay, so you can use this equation or this formula to calculate the quantity of a substance in a solution or mixture. All right, it doesn't have to be a liquid solution per se. It could be any type of mixture, but it is common for percent mixture problems to be working with liquids. Okay, and speaking of which, as you might have been able to guess, this equation can be used to help us solve percent mixture problems. In fact, we will use it multiple times to help us build equations that we can then use to solve percent mixture problems, which will involve two solutions being combined to make one mixture or solution. All right, that's the type of problem that we are going to focus on solving in this video. And so let's take a look at our first example. All right, so for this problem, we want to know how many gallons of a 15% acid solution must be mixed with 4 gallons of a 20% acid solution to make a 17% acid solution. All right, so in this problem, we were actually working with 3 different solutions, but all of them have a percent concentration for one particular type of substance. All 3 solutions have a particular percentage of acid within them. Specifically, we're mixing a 15% acid solution with a 20% acid solution to make a 17% acid solution. All right, that's always going to be the case in these percent mixture problems. You're always going to be working with the same substance, but it's going to have a different percent concentration in the solutions involved in the problem. Okay, but now let's actually talk about how we're going to solve this problem. For one thing, we are going to make use of the formula that we just looked at. the formula that Q is equal to A times R, or the quantity of a substance in a solution, is equal to the total amount of the solution multiplied by the percent concentration. And if you remember, what I said earlier is that we're actually going to use this multiple times because in these problems we are working with multiple solutions. In particular, we have two solutions that are being combined to make another solution. All right, so really we're going to use this equation 3 times, 1 time for each of the solutions in the problem. And so what I recommend that you do here, very similar to the previous lesson where we worked with value mixture problems, what I think you'll find helpful to do here is write out a chart organizing all the information that you're given in this problem, and then use that chart to help you build different pieces that then can be used to form an equation that will ultimately allow you to solve this problem. Okay, so here's what that looks like. What I recommend that you do is write down the two different solutions that you are combining. So in this case, that would be the 15% acid solution and the 20% acid solution, right? Those two solutions are being combined to make the 17% acid solution, which then we want to list below these two. So right here we have the 17% acid solution. Okay, and so then we can build the chart. You're going to have a row for each of those solutions, and then 3 different columns, one for each of these 3 values. And we're going to start with A, the amount of each solution. So for the first column, we will have the amounts A. Then for the second column, we'll have the percent concentration R. And then in the last column, we have the quantity of the substance in the solution. All right, and remember that A times R is equal to Q. Okay, and so now that we have this chart built, let's fill in the information that we know. And in this case, the easiest column to fill in will be the values of R, the percent concentrations, because those percentages are attached to each of those solutions, right? We have 15% acid here, 20% acid here, and 17% acid here. So just convert those percentages to decimals and write those in here for R. All right, so we have 0.15, which is 15% as a decimal, then 20%, or 0.20, and then 17%, or 0.17. All right, in each case, just move the decimal place over 2 places to the left, or divide those values by 100 to get the corresponding decimals. All right, but then let's move on to this column for A. Do we know any of these values? Well, we do know at least one because we're told that the 15% acid solution is being mixed with 4 gallons of a 20% acid solution. So the 20% acid solution, the total amount for it is 4 gallons. All right, so I'm going to write in 4 right there. The solution has a total of 4 gallons, but 20% of it is acid, and then that's it, right? We don't know any other amounts. In fact, what we're trying to solve for in this problem is the amount of the 15% acid solution, right? We want to know how many gallons of a 15% acid solution must be mixed with the 4 gallons of the 20% to make a 17% solution. All right, so this value right here, the value of A for the 15% acid, is what we want to solve for. We don't know it, and so we want to assign a variable to it. I'm going to let it be represented by X. All right, and because we let that be X, we now have a way to represent the amount of the 17% acid solution. Because remember, the 17% acid solution is being created by combining the 15% acid and 20% acid solution. The two amounts for those acids are being combined to make this acid solution. So the total amount of gallons for that solution will be whatever this amount is for the 15% acid added to the 4 gallons of the 20% acid. All right, so for the 17% acid solution that's being created, the total amount for it is X plus 4. So I'll write in X plus 4. All right, and so now we have filled in these two columns for A and R, and so now we can fill in the column for Q. Because remember, Q, the quantity of a substance in a solution, is equal to A times R, right? That's our equation here. So for each row, multiply the two values together, and that will be the value of Q, or the quantity of acid in each of those solutions. All right, so first up here, we have X times 0.15, which I will write out as 0.15 times X. And then next up, we have 4 times 0.20. So I'll just write 4 times 0.20. And then for the last row here, we have x plus 4 multiplied by 0.17. And so you want to remember to multiply that value by both of those two terms, so put parentheses around them. I'll write it like this. We'll have 0.17 multiplied by x plus 4. Okay, so now we have filled out the chart. Our chart is completed, and so now what, right? Why did we build this chart? What is the point of that? Well, here's what we can now do. Remember that these two solutions, the 15% acid and the 20% acid solutions, are being combined to make the 17% acid solution. So what that means is that the two quantities of acid in those two solutions, when combined, should be equal to the quantity of the acid in this solution. So what we can do is set up an equation where we take this quantity plus this quantity and set it equal to this quantity. And so that will look like this. We'll have 0.15x plus 4 times 0.20. So let's write that down. 0.15x plus 4 times 0.20. And that will be equal to this quantity, 0.17 times x plus 4. So I'll write that down, 0.17 times x plus 4. All right, and now we have an equation with one unknown variable, that being x, and so we can solve for it by simplifying this equation and isolating that variable, or getting it by itself. All right, and once we do that, we will have solved this problem because remember what x represents. We let x be the amount of the 15% acid that must be mixed with the 20% acid to make the 17% acid solution, right? That's what we want to find here. And so once we solve for x, we are done. So let's do that here. Let's start by simplifying this equation. First of all, we have 4 times 0.20, which will be 0.80 or 0.8. So we have 0.15x plus 0.8, and that will be equal to 0.17 times x plus 4. So here we want to distribute 0.17 through this quantity. You want to multiply it by x, and then add that to multiplying it by 4. Okay, we're just using the distributive property that we have looked at earlier in algebra. So 0.17 times x will give you 0.17x, right? The coefficient of x here is 1. So 1 times 0.17 is 0.17. And then you want to add that to 0.17 times 4. And you could do that work on the side if you'd like, or you could put it into a calculator. 0.17 times 4 will give you 0.68. All right, and now the next thing we want to do here is combine these two like terms, right? We have 0.15x and 0.17x. They both have that same variable part of x, so we can combine them, but do be careful. They are on opposite sides of the equal sign, so what we want to do is actually remove one of those terms from the equation by subtracting it from both sides. So in this case, I'll subtract 0.15x from both sides of the equation. That will look like this. We'll subtract 0.15x here and subtract it here. And so these two terms will cancel out, just leaving you with 0.8 on this side of the equation. And then 0.17x minus 0.15x will give you 0.02 times x. And then we still have plus 0.68. All right, and so now we just have one term with the variable of x, so we're almost ready to solve for it. But we do need to get rid of this constant term. We need to isolate this term with x in it. So subtract 0.68 from both sides of the equation. We'll have minus 0.68 here and minus 0.68 here. And 0.8 minus 0.68 will give you 0.12. So we have 0.12 is equal to 0.02 times x. All right, 0.68 minus itself becomes 0. And now we can finally solve for x by getting rid of this coefficient. We can divide both sides by 0.02, and we will have isolated x. All right, so divide both sides of the equation by 0.02, and if you do that, these will cancel out, just leaving you with x is equal to 0.12 divided by 0.02, which is equal to 6. So what we find here is x is equal to 6, which is the value for our final answer, but now let's put it into words. Remember what that represents. X is the amount of gallons of the 15% acid solution that must be mixed with the 4 gallons of a 20% acid solution to make a 17% acid solution. And we now know that that amount is 6 gallons. All right, so our final answer here is 6 gallons of the 15% acid solution. That is the answer to this percent mixture problem. Okay, and so this is the process that I recommend that you use for solving percent mixture problems. Be sure to make yourself a chart filling in the values for A, R, and Q, and then using the values of Q to create an equation that you can then use to solve the problem. Okay, and so let's practice doing this one more time with the last example for this video. Hey, real quick, before we get to the next part of this lesson, if you find my videos here at JK Math to be helpful, then I'd like to invite you to join my membership site JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out, as it's a great way to support me in the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Alright, so for our second and final example, we have a chemist wishes to make 3 liters of an 8% salt solution by mixing a 9% salt solution and a 5% salt solution. How many liters of each solution should the chemist use? Okay, so very similar to our previous example, we have 2 different solutions that are being combined to make another solution. In this case, we are combining a 9% salt solution and a 5% salt solution to make an 8% salt solution. So let's begin by drawing out a chart, and that will help us figure out how to solve this problem. So we have a 9% salt solution and a 5% salt solution, and those are being combined to make an 8% salt solution. Always put the combined solution at the bottom of your chart, but once you have those 3 different solutions written out, then start creating your chart here. In the first column, we will have the amounts for each of those solutions. In the second column, we will have the percent concentration, R, and then in the third column, we will have the quantities of the substances, in this case, the salt, in each of those solutions. And once again, remember that A times R is equal to Q. All right, and so let's start by filling in the percent concentration column, because we know all of the percentages. We have 9% salt, 5% salt, and 8% salt. So the decimal values for each of those percentages are 0.09, that's 9%, 0.05, that's 5%, and 0.08, that's 8%. Okay, and so then, what else do we know about this problem? Well, we know that the chemist wishes to make 3 liters of that 8% salt solution, right? That's the mixture that's being created by combining the 9% salt solution and the 5% salt solution. So the amount of the combined solution is 3 liters. So I'll write in 3, but then that's it. We don't know the other 2 amounts. Those are actually the values that we want to find here. We want to know how many liters of each solution should the chemist use. And so that seems a little tricky here at first, because that's 2 unknown values, and so you might be tempted to assign a different variable to each of them, but don't do that. Don't overcomplicate it. We only need to introduce one variable here, and I'm going to let it be equal to the amount of the 9% salt. All right, I'm going to let that amount be x. X will represent the amount of the 9% solution. And then since that is x, what that means for the 5% salt solution is that it will be 3 minus x, right? The sum of the amounts for the 2 solutions being combined to make the combined solution will be equal to the amount of that combined solution. We have some amount of liters here and another amount of liters here that combined will be 3 liters. So if this amount is x, then 3 minus x should give you the amount of this solution, because whatever this is plus this has to be equal to 3. So if you subtract out x from 3, you'll be left with what was from this solution. Okay, so the amount of the 5% salt will be represented by 3 minus x. Okay, and the way that you can check to make sure that you set this up correctly is if these 2 amounts added together equal this amount. And if you write out x plus 3 minus x, x and negative x would cancel out, they would add to become 0, and so you'd just be left with 3, which is the amount of that 8% salt. All right, so this is equal to 3, so that checks out. We know that we set this column up correctly. But now that we have those 2 columns filled in, we can fill in the column for Q. Just take A times R for each row and fill in that resulting value. So for the 9% salt, we have X times 0.09, which I'll write as 0.09 times X. And then for the 5% salt, we have these two terms being multiplied by 0.05. So make sure to put parentheses around 3 minus X. So we'll have 0.05 times 3 minus X. And then for the 8% salt, we have 3 times 0.08. And so I'll just write that like this. Okay? And so now the setup is the same as the previous example. Now that we have filled in this column for the quantity of salt in each of those solutions, we can create an equation by taking the sum of the two quantities for these two solutions and set it equal to the quantity for the combined solution. All right, this quantity plus this quantity will be equal to this quantity. Assuming you set your chart up in the same way that I did, that will always be true. Make sure to put the mixture solution or the combined solution at the bottom of the chart, because then you know that the sum of these two amounts is equal to this one, and the sum of these two quantities is equal to this one. And by the way, that does not carry over to the percent concentration, right? 0.09 plus 0.05 does not equal 0.08, so you can't add these two to get this one. That's not the case, so don't make that mistake if there's a problem where you don't know one of the percent concentrations. But it is true for the other two values of A and Q. Okay, you can add these two values to get the last one, assuming that that last one represents the combined solution. But anyway, let's set up the equation here. We're going to add this value to this value and set it equal to this value. So we have 0.09x plus 0.05 times 3 minus x, and that will be equal to 3 times 0.08. Okay, we have this quantity plus this quantity is equal to this quantity. And so now let's simplify and solve for x. We'll still have 0.09 times x, but then we want to use the distributive property on this term right here. We want to distribute or multiply 0.05 by both of these two terms, starting with 0.05 times 3. That will be 0.15. And then you want to multiply 0.05 by negative x, and so multiply the coefficient of negative 1 here by 0.05, and you'll get negative 0.05 times x. And then that will be equal to 3 times 0.08, which is 0.24. All right, and so now, further simplifying, we do have two like terms involving the same variable part of x, and they are on the same side of the equal sign, so we can just combine those terms directly. We can add their coefficients, 0.09 plus negative 0.05, or really you can think of it as 0.09 minus 0.05 is 0.04. So what we get here is 0.04 times x plus 0.15 is equal to 0.24. All right, we just combined those two like terms to get this one term. So now we only have one term with x in it. That's good. But before we can solve for x, we do need to get rid of this constant term. So let's subtract 0.15 from both sides of the equation. That will leave us with 0.04 times x is equal to 0.24 minus 0.15, which is 0.09. So we have 0.09, and that's it. 0.15 minus itself is 0, so that's gone, and this is all we are left with. So to solve for x now, we want to get rid of this coefficient, so divide both sides of the equation by 0.04, and so these will cancel out, just leaving us with x is equal to 0.09 divided by 0.04. And if you want to, you can try to do that calculation by hand. I'm not going to show you how to do that here because that's not the focus of this video, but if you do that calculation or put it into a calculator, you will find that x is equal to 2.25. Okay, so now what does that mean? We solved for x in this equation, but what does that tell us? Well, remember what we let x be equal to. We said that x represents the amount of the 9% salt solution. And what we're trying to figure out in this problem is how many liters of each solution the chemist should use. So we have one of those answers. We now know that he should use 2.25 liters of the 9% salt solution. And then for the other solution, the 5% salt, we know that the amount of that solution is 3 minus x. So you want to subtract 2.25 from 3 to get the amount of that solution. And if we do that work on the side here, 3 minus 2.25 is equal to 0.75. All right, so here's our final answer. The chemist should use 2.25 liters of the 9% solution and 0.75 liters of the 5% salt solution. Okay, that would be the final answer to this problem. We have found how many liters of each solution the chemist should use to make 3 liters of an 8% salt solution. All right, and so that is it for this lesson. This was our last example for this video, but if you do want to get some more practice solving these percent mixture problems, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.